Hello, my name is Nicholas and I'm here to help you evaluate an integral like this one. Now, in order to evaluate an integral like this, we can use something called U-substitution. And U-substitution is usually one of the methods that we try to use when evaluating a series of integrals. Now, in order to go about this integral, assuming that we are going to go try U-substitution, we first have to ask ourselves what term, this term, or even the ones inside of it, are we going to set equal to u? Well, one thing that you can take into consideration when you're trying to choose what you're going to set to u is this, I don't know if to call it an equation, but something that was given to us when we were discussing notes. And it goes something like this. The integral of g prime of x, f of g of x, and then you could say dx. And when you have something like this, you can set u to what's inside of this composite function, which is represented as f of g of x. And in this case, we would say, well, u is equal to what's inside. In this case, it would just be g of x. Now, to show that here, we can go ahead and try to evaluate this. So we have to ask ourselves, what are we going to set u to? Well, if we look at the denominator here, we see that this is an entire term. So if we can go ahead and get a different color so you can see what's happening. We'll do blue. We look at this integral and we can rewrite it as the integral of this top term in the numerator, which is x squared plus 4, which I'm going to put in parentheses so it's easy for us to see what's going on. And then we have this term in the denominator. Now we can bring it up here and we could say x plus 2, the term in the denominator, to the power of -1 dx. Now we can ask ourselves, which function is there a composite function of? Well, when we look here, we can see this term to the power of -1, and there's a term inside of there. And that is similar to what's happening here, because f of some function is f of -1, and in our case, g of x, the one that's inside of this composite function, is x plus 2. So we can say, as this rule states, or I guess we can say this observation, we can set u to what's inside of the composite function. In our case, this composite function here, what's inside of it is x plus 2. So we can go ahead and say u is equal to x plus 2, which is a pretty simple u, which is nice for us. Now, how do we go about this? Well, now that we have just established that u equals x plus 2, we can go ahead and plug it in. But before we do that, I'm also going to try to find the derivative of u with respect to x. So we can go ahead and take the derivative. Derivative of u is equal to, the derivative of a constant is 0 because it never changes. And the derivative of x times 1 is just 1 times 1. So we could say this is 1 times dx. And just to be clear, the dx is coming from the fact that if we did this instead, du with respect to dx is equal to 1, because it's the derivative of this with respect to x. And then you can just multiply dx on both sides. And you would get du is equal to 1 times dx is really just dx. But if you want, you could put the 1 there. It's up to you. So now we have just established the fact that u is equal to x plus 2, and the derivative of u is equal to the derivative of x. Derivative of x, which we see here. So now we can go ahead and plug in our values. So we have our integral. We haven't changed this yet, so we can leave it as is for now. X squared plus 4, keeping everything in parentheses to keep it simple. And then we have this here, which we said x plus 2 is equal to u. So we can just go ahead and plug for u. And we said that this term is to the power of -1. Now we also established when we took the derivative of x plus 2 that d of u is equal to d of x. So anywhere we see d of x, we can replace with d of u, because we're trying to evaluate this integral with respect to u. So let's go ahead and get rid of d of x and replace it with d of u. So now we have this term here, x squared plus 4 times u to the -1, d of u. How do we go forward? Well, we need to find a way to get rid of the x's. That's our main goal here. So we have to look at what we have in order to get rid of this. we see that we said that u is equal to x plus 2. So we can go ahead and rewrite that so it's clear what's going on. Let's go ahead and say that u is equal to x plus 2. So how can we get rid of this x with this term here? Well, we could simply isolate the x and say what x is equal to with regards to this term with respect to u. So we could just say x is equal to minus 2 on both sides, u minus 2. And anywhere where we see an x, we can plug in this term. So let's go ahead and do that. So we write the integral. We see an x squared. So I'm going to write parentheses, and I'm going to replace this x squared with a parenthesis so it's clear what's happening. And recall that we are saying that x is equal to u minus 2, and this is x squared. So now this becomes, because we're replacing it, u minus 2 squared. And don't forget the plus 4 outside of the parentheses. Plus 4 times u to the negative 1 with respect to u. Now we're getting very close to being able to evaluate this with respect to u in a way that's easy. I'm going to go ahead and change colors, and I'm going to go ahead and some people say FOIL, some people say just distribute. I'm going to go ahead and FOIL this out, this u minus 2 squared, so we can go ahead and put it in a form that we could evaluate. So I'll go ahead and make it green so you can see what I'm doing. In fact, let me go ahead and do red. So we're going to go ahead and say that u minus 2 squared is equal to, well, u minus 2 times u minus 2. And we can go ahead and evaluate and distribute. U times u is u squared. U times negative 2 is minus 2u. Negative 2 times u again is minus 2u. And negative 2 times negative 2 is positive 4. Go ahead and add like terms. We have u squared, doesn't add to anything new. We have two terms of u, so we have minus 2 minus 2u, so that becomes minus 4u plus 4. Now we can go ahead and see that this term here is equal to this, so we can go ahead and replace it where we find that u minus 2 squared. And I'm going to go ahead and go back to blue. And here's our integral. So like we said, this u minus 2 squared is equal to this term here. So I'm going to go ahead and write that in parentheses. U squared minus 4u plus the constant of 4. This is the constant I'm talking about. And then we also have this plus 4 here, because we have to recall that we are plugging in u minus 2 squared right here where x squared is. But there's still that plus 4, so don't forget to add that 4. Okay, and then don't forget the rest of your terms as well. So we have u to the negative 1 power with respect to the derivative of u, or excuse me, with respect to u. Now, let's just simplify this out. We get u squared minus 4u, this is 4 plus 4, so plus 8 times u to the negative 1 power with respect to u. Now, all we have to do is distribute this u to the negative 1 to the rest of this term. So I'm going to go ahead and move it over here with an arrow. I'll go ahead and do a line over this so you don't mix up what I'm doing. So let's go ahead and distribute this u to the power of negative 1 to all these terms. So we go ahead and do that here. We say u to the negative 1 times u squared is essentially u to the power of 2 minus 1, because they add. So let's go ahead and do that. So we have u times that. U to the negative 1 times 4u is just negative 4. And u to the negative 1 times 8, this constant, is really just plus 8 over u. And the reason that is because when you have a u, this u is not canceling anything in this 8 because there's no variable of u, it's just a constant. So it really is just 8 times u to the negative 1. And in order to make this positive, we move it to the denominator, and it becomes positive exponent of 1. So we get 8 over u. And remember that we are saying this is with respect to u, this integral. So we write it like that. And now we have it in a form that's easy to integrate. So I'll go ahead and integrate it for you. We can simply say that the integral of u du minus 4 of the integral of some constant 1 with respect to du plus, this is 8. So we could just say 8 times the integral of 1 over u with respect to du. And don't forget your du's on every integral that you write. It's very important for the person who's reading this, because you don't want them to assume something that you don't mean. So now that we do that, we can go ahead and simply evaluate our integrals with the rules that we've learned. The integral of u is simply u squared over 2. 4 times the integral of a constant. Well, the integral of a constant is just the variable. So it's 4 times that constant, the integral of a constant, which is just 4 times u. And then we also have 8 times the integral of 1 over u, and the integral of 1 over u is ln of the absolute value of u. So it'll be 8 times the integral, which we said was ln of the absolute value of u. And since this is an indefinite integral, we go ahead and add the constant term, plus c. Now, although this looks done, we have to recall that u is simply equal to x plus 2, as we stated in the beginning. And all we have to do at this point is plug in x plus 2 where we receive u. So we can write it like so. We have a u squared over 2. We write that as x plus 2 squared over 2 minus 4 times u, which is equal to x plus 2. And then we have plus 8 times ln of the absolute value of, we just write, x plus 2 plus c, the constant term. And that is it. That is our answer. Go ahead and square that for you so you can see which answer I'm referring to. This would be the answer that you should put on an exam or a quiz or wherever you're asked, just to really show what you mean. Thank you for watching this video, and I hope it helps you. Have a good one.